All right, so this last portion of chemistry is actually all about looking at the bonds that are made when we have compounds created. So looking at when we have different atoms, how do they actually chemically connect to make larger compounds? So there's two main types that we're going to be discussing. So when elements form compounds, there are changes that happen to the arrangement of the electrons, right? So they go from being, let's say, single particles, right, to now being connected to each other, and perhaps in multiple different combinations. So how these atoms come together is actually through the changing in their electrons. So what happens is there's two scenarios. Electrons are either going to be shared between the atoms, so electrons can be shared from one atom to another, or electrons can be transferred, which means that one atom will give electrons away and one atom will actually accept them. So the goal of creating compounds actually is always the same. Atoms want to obtain a stable electron configuration. So what that means is they want to have a full valence shell. So remember, the outside electrons are called valence electrons because they're on the valence shell or valence energy level. And essentially what the atoms would like to do is either gain electrons to make that last orbit full, or lose electrons so that the orbit that's underneath is now full. So essentially they want to become like the noble gases. So all the noble gases have a full outer electron, a full outer orbit. So I'm just going to quickly go over a little kind of trick on how to know the number of valence electrons. So remember, when we're talking about this sharing or gaining and losing, it's always the valence electrons that are involved. So actually, an easy way to know how many valence electrons an atom has is by looking at the chemical family or group that it's in. So column number, so let's say 1, 2, 3, 4, 5, etc. This is 13, 14, 15, 16, 17, 18. Remember, there are 18 groups on the periodic table, so this goes all the way, of course, to 12 here. Okay, so valence electrons, by looking at the group number that they're in, actually is a nice quick way to figure out how many outer electrons they have. So everything that's in group 1 has one valence electron. So if you were to draw the Bohr-Rutherfords, you will see that. Also, their charges will be a positive 1. But we're gonna talk about charges later on, actually, in this lesson. What I want you to focus on now is the group number and how many valence electrons they have. So everything that's in group number 2 has 2 valence electrons. Okay, but now we're going to skip over a few. So these transition metals, this center block, does not follow the pattern that I'm teaching you here. So basically we're going to go 1, 2, and we're going to skip over a few and go to 13. Okay, now if you look at the last number in the column number, so 13, that will help you here. So group 13 has 3 valence electrons. Group 14 has 4 valence electrons. Group 15 has 5 valence electrons. Group 16 has 6. Group 17 has 7. And group 18, which is our noble gases, have 8, which is full. Now, the only noble gas that does not follow that 8 rule is helium. Okay, helium has only 2 valence electrons. But if you remember, the first orbit that we draw, the maximum that you can fit is only 2. So the noble gases are always at the maximum number of valence electrons. Okay, so there's 2 types of compounds that can be made, or 2 kind of categories compounds can fall under. So we have ionic compounds and molecular compounds. Sometimes molecular compounds are also referred to as covalent compounds, and you'll hear me kind of use both terms. So molecular and covalent mean the same thing. So ionic compounds do the transfer of electrons, so the give and take. Molecular compounds do the sharing of electrons. So if you remember, those are the two options. Electrons can be shared or electrons can be transferred. So ionic compounds are transferring, molecular compounds are sharing. So ionic compounds are made up of from positive and negative charged ions, and how the molecule, or I should say the compound, actually comes together is because opposite charges attract. So positives and negatives will attract one another. The electrons are transferred from one atom to another. So actually what's happening here is the positive ion is losing electrons, the negative ion has gained them. So one is losing and one is gaining. So this involves the bonding between a metal and a non-metal. So the metal is actually the one that will do the losing of electrons and become positively charged. The non-metal is negative because it's doing the gaining of electrons. So basically you have a metal atom and a non-metal atom. The metal atom will give up its electrons to give to the non-metal. So as a result of that, the metals will become positive because it lost a negative charge, and the non-metal will become negative because it's gaining a negative charge. One property that's unique for ionic compounds is that when you dissolve them in water, they actually are able to conduct electricity. So the proper terminology for that is that they are electrolytes. So for example, if you ever drank a Gatorade or anything that has like an electrolyte drink, usually it's because it has ionic compounds dissolved in it. So an example of an ionic compound that everyone probably knows is salt. So we're going to get into more detail of ionic compounds later on. Okay, so a molecular compound or covalent compound, sometimes we refer to them as just the term molecules, right, for molecular. So these are not charged. So you know how we just finished saying ionic compounds have positive and negative charges? These molecules are neutral. Okay, what's happening is the electrons are being shared between atoms. So the bonding that happens here is only with non-metals. So that's another big difference. Ionic compounds is a metal with a non-metal. Molecules or molecular compounds are only non-metals. So I'll give you an example. Water. Hydrogen and oxygen are both non-metal elements. So non-metal elements, when they dissolve in water, are actually not able to conduct electricity. And the reason why is because they're neutral. In order for electricity to be conducted, there has to be a charge. So another example of a molecular compound is glucose or sugar. So when you dissolve glucose in water, that cannot conduct electricity. So salt in water, yes. Sugar in water, no.